Right. Hey, this is Coffee Compiler Club. We're here today talking about C++ iterators, C++ audiences of using speakers and compilers and language runtimes and Elton John concerts and anything else that comes around. It's a casual conversation. I'll try to keep it sort of kind of on track with language implementations. No bets. And, open mic, say what you want. I'll moderate if I need to, and then you're all being recorded and you'll be up on YouTube within an hour. And that's the end of my 10-second spiel. So, whatever people want to talk about, I'll open up by saying Cameron sent me a link to discussing some C++ variation update on how to talk about pointers and references. And I stared again at the C++ pointer reference model and was just like, oh God, this is like complexity for complexity's sake. Followed by a link to a guy talking about how to rethink C++ pointers, which was okay, kind of slow going. Followed by a link to a guy talking about C++ iterators, which holy crap, did that get crazy. There's a bajillion ways.
I would argue it's complexity for backward compatibility's sake, but sure.
It's incredibly complicated. And everyone in the audience had strong opinions that you were fucking wrong, and I'm going to tell you why you're wrong. And I don't want to interrupt your talk, but you're wrong. It's like, I agree to disagree. You have an opinion? I have an opinion? No, you're wrong. It's like, wow, dude. And it wasn't just one person. It was a bunch of them.
I stuck the link in the doc.
Yeah. Oh, for your carbon thing?
Yeah.
I chased into the conference talk, which was okay, slow going. And then I got bored because the guy was going slow and not saying too much new. And then I followed the YouTube suggestion to the iterator one. That one got hairy fast. And I think that the speaker had a good point. He was being completely fair. And
what was the iterator talk? Do you remember the title of the offer?
It's up right now. I was just staring at it a second ago. C++ now, why iterators got it all wrong. I'll throw the YouTube link in the chat and into the doc. I got as far as, here's another person showing up. I got it as far as some iterators return you an element, like you find an element with an iterator. Some return you a border between two elements because you're looking for an edge condition of some kind. There are filters and transformations. And when we unwind filters for an element, you generally get a reasonable thing. But if you unwind a border between elements on a filtered view, the new border position is ambiguous on the original underlying set. And let's think about this problem. And people just crawled all over his ass, lit right up, and just like start chomping down.
Oh yeah.
He couldn't get two steps forward into his talk, and I had to skip like 20 minutes of people being abusive.
That's C++ now. I mean, it's kind of a feature. You come there and to give a talk expecting to be heckled. You want your ideas challenged. So it's a very specific to this particular conference.
Oh, good. All right. So the speaker was prepared mentally.
Yeah. You go there to get critical feedback basically, and he got
boy, there was some critical. Definitely some critical speaking going on. I wouldn't necessarily claim it was. I don't know. I'm in the zone of we can agree to disagree. Like I think something's different, and I don't like what you're doing. That's all fair. But you're wrong, they were just open. I don't interrupt your talk, but you're wrong. Dude, fine. And pretty clearly, I mean, the presentation showed this is ambiguous. And so there's room for people to agree to disagree in an ambiguous situation. And no, this, that, whatever, just fine. All right, never mind. So I threw in a war of words for the people who haven't seen it before. It's a talk specifically targeting programmers and people with conflict avoidance behavior and might help you understand yourself a little better. And if you've been down this path long enough, nothing I say in there is new or exciting. And if you've not seen this before, it might be an eye-opener. So sometimes it's worth it. And as Cameron says, that one has been popular for a long time and comes around fairly often. Actually, now that I've opened my trap, I wonder, this is the GCon version of it. No, it's kind of topped out at 1,000 views. It was crawling up fairly rapidly. I've given it a bunch of talks, so I don't know who's watching what version of it now. It's out there.
Good investment of time, though. Definitely. worth the
Yeah.
watch.
Well, thank you. And I don't have much else to say here. AA wise, I got my overloads where there were no errors in the program doing what I wanted. And when there are errors in the program, I got really ugly answers, and I'm busy trying to do what I did for all the other errors in AA, which is to say they are, there is a most general format or a most specific type. There's a best typing. And so I have to come up with what that means for error situations, so I can report to you a consistent, reliable error if you've blown your overloads. If you have ambiguous overloads, that's the only trick. It's you have ambiguous overloads. What I do. And for Alan's case, I went ahead and removed the functions only requirement. You can put any two crappy types you want in an overload, and in fact, I pick them out, and it's all good as long as it's not ambiguous. And if it's ambiguous,
That does sound like a win.
It does what?
I said that does sound like a win. It's
I'm
just
not-
one less thing to keep in your head for how the language works.
Yes, that part's fair, but it's like I'm not clear what the programmer use case that's useful is. I have an element, a name I'm going to refer to. It's actually an overload. In one instance, it's the hex value for the red color. In another instance, it's the quoted string red, for instance. I have a collection of these. I pull a color out of my collection because I pulled a color somehow, and I just use the word color as a variable wherever, and I'll either use it as the hexadecimal bits for RGB, or I'll use it as a string, and I can deduce all the overloads out of it fine. And so it's like an untagged union in that kind of sense. You know, it's effectively a tagged union, except I don't need to look at the tag because I know it from type.
So the closest thing I've seen to that kind of use case was a system that, for weird reasons, if the input was 0 and the input was 0 99% of the time, you could do a really cheap algorithm.
Right.
And that was really fast.
Right.
And if it was an integer, then you could do a medium expensive algorithm. And if it was a float, then you had to do the expensive version of the algorithm.
Okay.
And
Well,
we
you
ended
had
up getting a significant performance win first by saying, we're going to overload this thing and have one implementation for ints and one implementation for floats. And then it turned out it was useful to have one implementation for zero and one implementation for ints and one implementation for floats.
Okay, but somebody had a thing that was typed as an int versus typed as a float.
Right. And we created a new type that was this is a 0 case, and overloaded on the 0 case type that we made in order to make that one work.
No, I'm coming around to they had a runtime test to distinguish int from floats, not a compile time type test to distinguish int from float.
So the same algorithm was used in a bunch of places, and in a number of them, it was always 0.
So they had a compile time knowledge that was frequently 0 here, and they wanted to say, and now we do the foo algorithm, but it's on a 0, so yeah, whatever, it's cheap.
Right.
Yeah. Okay. Yeah. Fine.
But yes, I think I've seen one time in my entire career where that might have been useful.
Yeah. Right.
Mostly, I think the win is that it's one less thing to keep in your head about the language.
Yeah. Okay. Maybe. Right. Like I want overloads for functions, and then specifically for the int plus float versus widening variations. And then after that, I'm like less excited, but overloads are happen commonly for functions. And then after that, because the typing system totally allows it, I have to handle the broad general case specifically to support.
Okay, so there's one case where it's really useful, which is bounds of integers. So you say like min bound and max bound, and they're overloaded for all of your integer and float types. And so then you can just say, max bound, and it'll get resolved to whatever the maximum bound of the integer type you're using is.
So for me, those things come as static properties of the first element, which is an int. And so I can say 3 dot max int, and that'll just give me, and there's no overloading here because 3 is unambiguous.
Okay. I'll be
I have to have some set of interesting choices. So functions give me a bunch of things. Oh, here's Cameron saying goodbye and eval in the same sentence. And I don't want to deal with method handles. I'm not dealing with method handles, but I have other ways to do the same effect. So fine. Yeah. Yeah, the general case for me is, does an overload type, pick one of the overloads that types, and there can be only one or you're in error. And in the case of your int, I only have the one element on the left. There is no overload resolution in that sense, because I always have to strongly type the one element on the left. The remaining elements are all get inferred for a function, and everything's a field load off of the guy on the left. That's the current schmick I have to cut down on the language features. They're only fields. They only get loaded off of the guy on the left. That covers methods. That covers all your static properties out of classes. It covers a butt ton of things. Okay. Yeah. Otherwise, it sounded good. I'm looking for use cases because I'm abusing myself trying to get the damn errors sorted out. And I want to move on past this. And I think, knock on plastic, this is yet again the last extra language feature that I kind of sort of want a hard theory on before I go finish out the AA. Like I started down AA from the last go round when I had sorted out whatever I was sorted out then. And then suddenly right away in my test cases were like, oh, okay, let's do int float resolution and decide how to widen or not. And then, geez, promptly fell into that typing rat hole. All right, something else. Somebody else's turn. We lost Matt Chernick.
I actually have some questions about inlining.
Yeah. Yeah.
So I don't know if you guys are interested in talking about that topic, but so I haven't found too many good resources on, methodologies out there. I found one really good paper, I think, called Fast and Effective Procedure Inlining by Waddell and Dybvig.
We'll throw a link in somewhere, but I've obviously done the inlining game for a very, very long time.
Okay.
And actually been fairly successful at it. What am we doing here? Okay.
Let's see.
And then the main trick with inlining is it's all context dependent. What are you doing and where are you at decides what kind of inlining to do.
Yeah.
You were static compilation of a dynamic language. Is that, I don't know, I'm trying to remember what you were last week or what you were working on.
So I'm compiling. It's not a dynamic language. It's pretty static. It's pretty simple in terms of I'm mostly dealing with ints. And, it's just a controller to drive an accelerator, but the main data is not flowing through the program in the controller. It's sort of
right. So some math algorithm that's deciding pick from column A or column B or whatever.
Not really. It's more like basically driving the hardware to run a convolution algorithm or something where you're saying, okay, pull in data, build a window, run the accelerator on the data now that it's here, push it out here.
Well, okay. So if the controller has a fair amount of memory, there's the obvious inline it all strategy. Like you have no recursion.
Yeah. So I guess inline it all is a possibility. I don't think I'll be able to do that. I mean, I might try it in the beginning.
Yeah, fine.
Well, okay. So I might have 8K of instruction memory to work with, and that has to also fit my stack.
Yeah, fine. Okay, so you got really tight issues there. Well, then do sort of the obvious things, and that's count loops. Loop nesting depth. Take your innermost loop, inline everybody that's inside the innermost loop.
Yeah.
and leave it off at that. You can also say shit like it's super small, inline it. All your getters and setters are all super small. They're generally less code to inline than not inline. Otherwise, you make an approximation of what's hot. And the easy approximation is to say it's in a loop.
Yeah.
And only the innermost loop counts. Everyone else is already multiplied by the frequency of the innermost loop. So inline and innermost loop, and then, you know, walk away from it.
Yeah. 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 Oh, that's probably what I'll start with for.
Yeah, at 8K, I don't know how big your controlling programs get, but then there's a whole set of embedded guys talk about iCache footprints. If you have a fixed memory size, then you land in, it's not even iCache, it's just like it has to fit or it don't. But there's a game to be played where if you know more information, you can pick better about what to inline and what not, just to fit.
Yeah. Yeah. There's also the possibility to hot swap parts of the program, but that seems complicated.
It's a overlay linker. Holy shit, I haven't done overlay linker since I was, 20s. But sure, 40 years ago, overlay linkers was hot technology. What the hell? I'm sure some embedded guys do it. Yeah. There was full-on solutions that would automatically do that overlay game for you if you just picked out the parts that were to overlay.
So the term, I had to write this down. Overlaid linkers, just so
overlay linking. Yeah. I leave this chunk of code behind and I go back to some top level and I throw this chunk out and I throw some other chunk in and I call what I want. It looks like a standard C program I'm running, but there's a giant phase shift between that the linker was inserting code to yank and pull chunks in and out. Then iCaches came along and it probably went away.
Right. Unless you're trying to keep things really small.
Right, and you have to pay. Well, no, yeah, your hardware is so small, it's not caching over a larger memory, but it has access to a larger memory, so you can get at the extra data that doesn't fit in your program code state.
That's right.
So I'm just saying, So there's some games we played if you're doing it manually, like I have 8K. I'm going to take 4K for the top level control, including overlay, and then I have 4K for algorithms. And when I call an algorithm, I expect it to run to completion as a giant phase. And when I call it again, if it's different, I'll stop, go back to however I read from the CPU control, somebody else with big memory, and say, give me this piece of code. And then I'll throw it in the 4K and then I'll call it. And when it's done, you set up the next go around. Yeah. Not claiming you should do that. I'm just saying if you really need to squeeze in 8K and you have more code than squeezes, then yeah, you're looking at overlay games. And once your data path is like saturated, you don't need any more performance out of that controller, right?
Yeah.
Yeah. I would just start with it's tiny and inline it. And it's inside a loop. So raise the tiny threshold to be somewhat larger and inline that. If you have big functions in loops, it doesn't matter because the big function, you're avoiding the overhead of having the call or callee save argument shuffle by inlining. And sometimes in the case of loops, you can haul shit out of the loop and be loop invariant.
Yeah. There was something that occurred to me. I don't know if it's possible. I'm sure it's something people have thought about. Is it possible to take a function and say, okay, forget about it calling it as a function, treat it as a basic block with multiple entries?
Multiple entries?
Yeah, so like you have, SSA code has phi nodes, right? So like a loop has multiple ways of entering it. And so like what if you treat function body, which you don't want to inline like that, say I only have like a couple of known usage points, and I just basically say, okay, I'm not going to treat it as an actual function. I'm just going to phi my way into it.
So that's how I represent functions in C2 and in AA already. And then on a case-by-case basis, I'll decide to jump on the inside, like bypass the merge point. So what you just described there, you have a merge point where a bunch of people can jump in on it and then jump out.
Yeah.
In like the 60s and 70s era machine hardware, that was what a function was, and you couldn't be recursive, and you had a return address. So when you jump in and you expect to go back, you have to pass in a return address.
Yeah.
All modern hardware puts that return address somewhere. Jump and link register for if you're an IBM, if you're an Intel, it goes on the stack. If you're an ARM, it goes somewhere else. When you return, you just do a register jump to the return address. You only have one of these, so you can't be recursive because there's no stack involved. That's a common hack. It's not going to be any faster, I think, than a call and return unless your controller hardware is of that era of technology complexity. So if you think you have some code which you want to inline in some places and not others, and it's hot enough, you might try making it a macro, and then having one instance of a macro that you wrapped in a function header that you're just going to call like a function, and other places you use the macro directly, and that will just, you're manually inlining on a case-by-case basis.
Yeah, I could do that.
What's your controller hardware do for function calls? Does it have any function call support at all?
Not really. No, it's I mean, we have a swap call, so I can swap with the program counter into a register.
Yeah, that's branch and link and another name. Fine. Yeah.
So your program counter is not just treated as one more register. It just happens to auto increment.
It is treated as another register. It's register 0. But I haven't experimented with storing extra information in the top bits of the program counter to see if I can, but I was going to.
Yeah, you better go ask the hardware guys. They'll tell you if those bits are actually there or not.
I was gonna say, if you mess with the top bits, it's not just gonna segfault on you.
No, almost always when you go to like these tiny embedded things, the theoretical statement for the program counter is X bits. The implementation is whatever the hardware is actually doing. It's only got 8K, it's only got like 13 bits. So if you store, they probably go into the black box, and if you load, they come back as zeros. That's probably what happens. No segfault.
Probably.
Yeah, and no way to store any bits there.
Probably.
So if you have a swap, that's your function call already, and your function call entry says, or when you make the call, you swap the program counter for the call, and you put the swap into another register. That's your return register. This is exactly as old school 60s and 70s. If you want to stack it, you throw it on the stack and you increment a stack pointer. If you don't want to stack it, then the return is jump to register 1, which is move register 1 into register 0, and away you go.
Yeah, and my register 1 actually is a prefetch, so it'll prefetch the cache. So it should make it a no delay jump if I have this thing I want in that register.
Okay. I don't know if register 1 is the one you want or whatever. I'm just saying.
Yeah, no, that's,
have a function call.
Yeah. So, yeah, so that's what I was saying is that's a piece that I have to should take into account, because I can basically save myself the little instruction fetch cache miss if I make use of it.
Yeah, and acknowledge that you're not allowing recursive functions in the controller.
That's right. Well, yeah. So, one thing I was thinking about is doing this only as an optimization and doing regular full function calls.
What's a full function call?
Well, with the proper preamble and store away the column save register.
If you have access to the whole program, you're not building linkable components, you're building the whole program, which at 8K you should. Then the compiler should totally run through and say, and this guy doesn't get called recursively, so he only ever needs to do the call in, call out game.
Yeah.
He's done.
Yeah.
And there's no more preamble other than if I'm calling out to somebody else, it's callee save registers are going to crush the one that has the return, and now I have to spill around that. But on
I was going to say, your callee and caller better agree on how to save registers.
Yeah, you just mark them callee, caller, save, and the register allocator in theory takes care of that. That's the allocator's job. And which would turn you into a standard function call with an optimization at the leaf is I moved the return into a register 1, it didn't matter which one, and then on exit, I just jumped to 1 or moved 1 into 0. And
Yeah.
the-
Yeah. And was it I was reading a few papers on register allocation. Was it yours that you say, forget about doing a special block where you save all of I can't remember if it's caller or callee save registers,
right. Yeah,
and just sort of keep them as live ranges, and you split them if you need to.
yeah. And then once you run out of registers, if a live range doesn't have any direct register-like uses, the register allocator puts it in a stack slot,
Yeah.
which is also colored, and you have an infinite number of stack slots.
Yeah.
You get this really tiny stack space consumption, and you get a good allocation in general. There's a bunch of other games going on. Yeah.
One of the things I didn't understand in your paper was why it's beneficial to not, like, basically remove how you get a benefit from removing the trivially colorable nodes,
This is
because
graph coloring in
people think
general.
it's the same problem, but it's like, I don't quite understand how by removing those, then nodes that would have spilled suddenly have less interference. Like, I don't understand that.
Okay, so the game being played here is in a particular graph shape. I have some things that are trivial and some things that are not. If I color the trivial guys, the guys who are not may or may not have so many conflicts that they can't get a color. So just because you have more edges doesn't mean you can't get a color. It means you can't obviously get a color. If it happens to be that all your neighbors pick amongst a small set of colors, there's some leftovers for you. So by taking the trivial ones out, I reduce the set of neighbors for everyone else in the graph. Those neighbors, now some of them become trivial as well. And what I've really said is there is an order which I can assign colors such that I will mostly pick the same colors for these trivial guys who don't matter what I pick. And that will leave extra colors left over for guys who have trivial neighbors. And suddenly they'll become trivial to color as well, recursively. So you take the complicated graph and you eat out all the guys who are trivial. It got simpler. Those guys will now have a leftover color that, based on who they have at the moment, and the trivial guys are going to get colored anyhow when I'm done. So the leftover guys will get whatever their constraint is, and the trivial guys who come later are going to get colored. I don't care. But now some of these leftover guys got trivial, so I can yank them, and I get a stack of ordered things of how the order I want to color. And I keep going down until I get the whole program, or I come up with a hard knot that I can't guarantee color.
So is this different from just doing the work in a specific order? Like, if I sort the list by most interference.
Right, it is different because you don't know who will have less interference as you pull the trivial guys out. There's no statically available, easy to look at property that you can sort on here. Most neighbors won't work because I'll simply keep pulling trivial guys out, and the guys with most might actually become trivial in the end. And some guy who only has 10 neighbors still has 10 neighbors when you're done, and you only got 8 registers, so you got to spell them.
Right. And so then, so you pull the trivial guys out, and you just sort of save that information for later. I guess you need to put it back into the graph later, right?
You have to put them back in the reverse order you pull them. So I do this hack where the live range is represented as an array with a length count. It's like an array list, like a standard Java array list, which is a standard doubling array. So I'm an array with a length as a part of the situation. Yeah. Okay. When I pull a guy out of the middle, I shrink the array by taking the last guy, put him in the middle. Take the guy I pulled out, I put him at the end past the length. As I keep shrinking the array, I keep putting the guys I pull out at the end. They become my stack order that I'm going to unwind at. So when I get down to the point where random rate is 0, everyone's trivially colorable. I now want to reverse and color it in the order that I pulled them out. So I take my length of 0, I make it 1, I pull the first guy up. He has to be trivial by the definition of how I got here. So he's colorable, I give him a color. And then I go find his neighbors and I bump them as well. And then we begin unwinding one at a time by pulling the next guy on the end of the list. He has to be trivial, you know, and because he was trivial at the time I pulled him, so he's trivial going backwards, and you unwind in that stack order. So you don't need any more storage space. You basically end up with a sorted list in the array that you're sorting in place according to trivial colorability.
Yeah, okay. So I want to try and rephrase this using the language of immutable data structures. So
I'm mutating the hell out of this, by the way. So immutable is probably a bad plan.
yeah, no, I mean, I'm
You do the enclosure.
take an algo and rework it. It may be a little bit slower, but hey, my programs are only 8K.
Yeah. Okay, fine. You could make an escape hatch to Java for a Java array list.
Oh no, I always can. I can.
Fine.
But one of the things that I do, and maybe I'll show this out at some point in the future thing, is every pass that I do, I can actually produce a list of the intermediate state after every pass. So it makes the whole thing really easy for me to debug and stuff. But
okay. There's a really great, really old paper where some guy proves the before and after coloring preserves the semantic of the wide ranges independent of what register allocation you use. So for testing, it's a cool thing. It basically tells you at the end of allocation and coloring, you've got your register allocation done. He tells you that you actually preserve the semantics from the start. So go find that paper. I don't have any remembrance of what the name of it was, but there's totally a paper on testing register allocators. It's an easy, slick hack. Go implement that hack like step 0. And then, all your bugs will be in your face right away, as opposed to, days later when you're sitting on the simulator and it's like, what the hell happened here?
yes, yeah.
Okay, sorry, go ahead. Yeah, you want to do immutable structures, so go do immutable structures. I don't care.
Okay, yeah. So I just want to make sure I have the concept. So basically, you start with an interference graph, and everything is in the sort of category of it must be non-trivial. But actually, that's wrong. There's a bunch of stuff that's trivial. So then you start moving. So you basically have one set of interference for each node, which is non-trivial, and another set which is trivial. And so basically what you're trying to do is move the data from the non-trivial set to the trivial set, and then you do the allocation on the non-trivial set first once you've sort of iteratively minimized it. And then
I would have said a little differently, but maybe I have a set that I don't know about. I look for a trivial guy. Having found it, I pull him out and put him on a stack. And then I repeat that. Now, the neighbors of the trivial guy I removed now may have become more trivial.
Yeah.
So then I have a work list algorithm where I pull people who I need to inspect off. If they were trivial, they got pushed on the stack. If they weren't, I ignored it and kept going.
All right. Yeah.
And when I pull a guy off, I put his neighbors on the stack. So I work this stack algorithm down. It's a work list until I get a notch that's not trivial.
Yeah.
At this point, I pick a dude who I think I might be able to color if I'm lucky, and I pull him anyhow, but he's not necessarily colorable. And I put a little tag on him saying, I may or may not be able to get this guy. Having pulled a dude out of the graph shrunk. I now have more trivial guys, and I repeat the trivial process. Eventually, I boil down to empty, and I'm done. Now I have a big old stack of guys, many of which are trivial. A few guys in the middle are not. Now I unwind. If you're trivial, I'm guaranteed a color. I can assert that I'm going to get one. I color you, and I keep going. And I rebuild the interference graph. I pull a guy off who's not trivial. He might get lucky and get a color, and he might not. If he gets a color, perfect. Give them a color, carry on. The next guys are trivial, they'll get a color, and you unwind out to the end. And if you did it that way, you walked away and you were done. If you fail because the guy who wasn't trivial doesn't get a color, you have to spill him. So I flag
Yep.
him on the, I'm going to spill you, but I keep going because several of these guys are going to be in the work list. I'm going to find all the spiller candidates in a minute. So I unwind, keep going until I find the next guy who might not color. He did or he didn't. And when I get to the end, I have a set of guys who failed. I now split them all aggressively. And again, if you want to get fancy, you can split around loops and you can split funny ways, or you can be simple and just say, what can you split everyone at every def and every use? Okay, you get a bajillion tiny little short live ranges and big ones, which can be stack colored, which you have infinite colors on, so they're guaranteed trivial. And then you go back around and you know, lather, rinse, repeat, rebuild your interference graph and try to color again. And the general theory here is on the first pass, you'll have many folks who have direct register conflicts and will never color, and you have a fairly high register interference graph numbers because some guys are just super hot, big live ranges. They have a ton of neighbors. This is like never going to color round one. Okay, at the end of round one and start of round two, you'll find that most everybody has the number of neighbors, or either trivial or the number of neighbors equal to your register color plus one, roughly speaking. And you probably get close if you're a small function, and you maybe miss if you're big enough, and you got a guy who couldn't color anything out. By round three, you almost surely will color. Occasionally on the land of Java, which you're not at, really big functions might go to 4 or 5 and you know, go rounds. And I quit getting clever after the third pass. I just said, if you didn't color, I cut you hard as I could to get a damn coloring done. But that was me optimizing, you know, cases that you don't care about there.
Yeah.
I had compilation time speed issues and didn't care in the end if you had a giant ass function and it wasn't coloring right away. I got brutal on it. Said I give up. Get the job, get the allocation done, get the compilation done, quit interpreting code, go. Yeah, so you pull things off the trivial pile using a work list algorithm, building a stack of colorability in reverse order. Occasionally have some losers who went on the pile, but that's just so you can make progress to the end. You unwind in color. If you got a color, you walk away. And if you failed, you split. In your case, I would just split fairly aggressively and optimize your code quality later. And you know, pass 2, probably you color completely. Somewhere between pass 2 and pass 3, you will color completely.
Mm-hmm. And so I need to reserve registers for dealing with sort of pulling data from. I don't have a way of doing an instruction with a memory address, so I need to reserve a register for that. Or
no, you don't. It's the allocator's job for that.
Yeah, I should leave that to the allocator.
Leave it to the allocator, yeah.
Okay, yeah.
So when it comes time to split, there's funny games like I have a value that I know is a constant because it represents an array pointer to memory that's been statically allocated for the big data heap thing on your big data platform. It's a constant. I can build a constant without spilling it. So when I split it, I will split it just at the use sites where I'll manifest the constant directly.
Yeah.
And then there's ones that say, I have defined this value by the calling convention of a not inline function, and it's coming in register as the return register 2 or whatever I put my return values in. And I'm setting it off in an argument in register 3, and I have a direct conflict between the return address where it manifests and the argument register needs to go to. That just must be split, and you split those on pass 1. So you're walking through, and you so the game I play here is every live range takes the intersection of the set of registers constraints that it's picked up. So if no one has any constraints, they get all the registers. If somebody says, I have to be in return register R2 or RAX on Intel, and I have to be in RCX as an outgoing, they pick up that set of constraints, which might go to empty. So when I come along and say, are you trivial? I take that into account. And if the answer is, I must be in RAX, but all the other register constraints are easy, I can put you in RAX without further splitting and without further coloring games or anything else. And so I'll just claim you're trivial and you're going to get RAX. That's fine. But if you have a conflict and you run the set dry, or the set of neighbors exceeds the cardinality of your set of registers available, you're going to have to be split. And then, you know, in the case of a hard conflict, I'll split you at every def and every use and walk away from that and make you free up. If you want to get clever around loops, you can say shit like, I have high pressure blocks and low pressure blocks and high frequency blocks and low frequency blocks, and you can play games about where I'm going to split you to try and preserve, the standard situation. You have two loops. You have enough registers for this loop, you have enough registers for this loop, but somebody needs to span this loop, but he's too complicated in here, so you're going to spill him around, but he wants to be in a register down here, and vice versa for the other loop. And so if you split around loops, you can get a slightly better coloring. In your trivial case, I wouldn't go there until that's like a second, third tier optimization after you get the first tier done.
Yeah. Okay. Okay. So I should let someone else talk, but I can ask more questions if you want.
I don't see anyone else jumping up down. They're all welcome to. We gave them enough time right here, right now, so pile in.
All right. So in the absence of other participants, I will ask a totally separate question about instruction scheduling.
Yeah.
So I was thinking about this, and so it seems to me that instructions turn into a graph, and you have basically register or very at this point it wouldn't be registers, it'd be variables. So variables being assigned in a very low level way, and then you have uses, and you have a graph with an arrow from the assignment to the use. And it seems like you could do a sort of force-directed algorithm to move the instructions around, and all you want to do is make sure that your arrow direction is always.
Yeah, you're very close to the correct answer here.
Okay.
There's a correct answer. So you need to first put instructions in basic blocks with a global scheduler. If you've only kept them in basic blocks, this is a non-issue. In my case, I lose the basic blocks on purpose and then rediscover them with a one pass. Once I'm looking at a basic block, the old school compiler wisdom, which surely holds today, is a standard list scheduler will get you 99% of the best possible layout you're ever going to get, and list schedules are trivial. And that's a case where you put people who have no inputs in the block first on the list, and when you pick somebody at random off the work list and throw them in the block, he has outputs that now got their prior instruction scheduled and they go on the list. And it's basically, you have a DAG now. You're looking at a basic block, you have a DAG, not a cycle, you walk the DAG and you schedule according to the DAG. That gets you like 99% of the way there. You can get slightly more clever by claiming you want to move loads up ahead of storage so you have time to cover the load use penalty, which basically means that I have a list of things that are ready to go into the block next. If there's a load, I'll put it first. And if there's a store, conversely, I'll delay on it so that the inputs can be computed before the store happens, sort of as far as possible. That will get you everything you want out of an instruction scheduler modulo some tiny, tiny fraction. And then you go into register allocation, and maybe you reschedule the spill code around, and maybe you don't. It's sort of now you're talking, nitpicky little this, little that. You can cherry pick 1% and 2% off of these numbers for a long time, and people have been doing it for 40 years on x86 do so, but I'd get it done first. And the easy one, list scheduler within a basic block. Easy to do, get you a good answer.
And what were you saying about throwing away the basic blocks and then rediscovering them?
That's sea of nodes. It's my fancy compiler game that I did way back in the day, and then ended up in hotspot, and it's worked great for 30, 40 years. So, what the hell? So sea of nodes says, I don't care what basic block things lie in. It's SSA form. I have a graph. I don't care what basic block things are, so I ignore that information as I build the graph, other than during the building. And there's videos even recently here on Coffee Compiler Club where I build a graph that's a sea of nodes. When I get done, I have a large graph without any basic blocks, but you can pick out a control flow graph in the middle if you want to. And I do a bunch of optimization on it. That's sort of straightforward stuff that you expect an optimizer to do, but it's on the graph format. It makes it fast, quick, easy, simple. this kind of graph actually work fine as Clojure as well. I know the Graal guys do it with Java. It's fine. There's easy ways to do it. You can inline on it. You can do a bunch of other shit with it. It's fine. When you're done with that level of optimization, which is all like what you can do with constant propagation and dead code elimination and value numbering, common subexpression elimination, and constant math, array address folding, all that shit. When that's all done, I go unwind back to basic blocks with a straightforward graph walk. That graph walk pays attention to my basic block frequency estimators. So prior to unwinding, I do a basic block frequency estimator. An easy one is to say loop nesting depth times 10. There's another one that says all my safety checks in Java never fail in practice. So I do a 99%, 1% split on safety checks. I don't know what your language looks like. You probably don't have the safety check question. If you have other tests like this is nil or not, or this mode works or doesn't, or is going or not going, you can usually do a 10-to-1 split if you think you know. Otherwise, use profile data if you know, and your profile data says you know. If you don't know, you make your guess. Okay, fine. So you get some block frequencies. Now you walk the DAG. Some of the places like fee nodes are stuck at basic block boundaries. So they force people to be in blocks or in block ranges. And there's a straightforward pass you find in the paper, Global Code Motion, Global Value Numbering by me, that talks about how the pass works. But it's really, it's a, you know, one up, one down. On the second pass down, you've got your blocks filled. Now that you've got your blocks filled, I do the instruction layout guy. Honestly, in what goes on in Java, I made a fancier version where I do the instruction layout at the same time I'm putting in the basic blocks, because I already have a list scheduler in action. It's just a global list scheduler instead of a block list scheduler. So it's a little fancier, but if you want to be simple, you can throw things in blocks and then do a list scheduler in a block. If you do it the way I did it, I actually skipped the list scheduling block because I had that effect already in the global scheduler. Fine. Now I have my blocks filled with instructions and I head off into the register allocator.
Okay.
And now that I've said that paper, I'm gonna go drag it up.
Yeah, I'll keep searching for this paper I was referring to before.
There's somebody in Washington quoting my paper. Here's the ACM Digital Library version of it. I have a Dropbox link I've dropped in the past. So I threw a link in the chat, I mean, not chat, in the doc. But all intents and purposes, it's a 2-pass, one going down, one going up, and deals with unwinding the CF nodes into basic blocks.
Okay.
And the
I
one
just-
hotspot. Go ahead.
The paper that I was talking about before, the inlining one.
Yeah. Did you get it in there?
Yeah.
The secrets of the Glasgow compiler inliner?
No, it's number 7. I don't know what number 5 is.
Okay.
Oh wait, somebody already found it. It's number 4. Huh.
I'm certain I've read this paper before. Yeah, this is like, right. Yeah, I in the land of hotspot predates this paper by a long ways. And of course, C compiler has been inlining since the dawn of time. I claim it's well understood effective algorithm to do, you know, loop nesting depth times 10 and inline and inner loops and small things. And then after that, you can get incrementally more clever. And the better way to get more clever is to pull up frequency data from profiling.
Yeah.
For your tiny 8K things where you probably have extremely hot loops and things that are kind of trivial and don't care for performance, I do exactly what I said. Inline and loops in the innermost loop at 1 threshold, and inline other things if they're smaller than X threshold, and have 2
And the
thresholds.
threshold is just number of statements kind of thing.
Yeah, anything you want that measures program size. It really doesn't matter what. I in hotspot, because I did inlining way too early, I measured in bytes of bytecodes. So bytecodes are big, bytecodes are small, bytecodes are different sizes. Some bytecodes turn into a lot of codes, some turn into little. On average, bytes of bytecodes, close enough. on average node counts and sea of nodes, on average size of compiled method all by itself. Doesn't really matter. Then you pick two thresholds, one for being in a loop and one for not, and you inline that way. You're done.
And the 10 that you were talking about in terms of in loops, that's basically a rough estimate in terms of how many iterations it's doing, right? So if
right.
you
If
know
no
how
one
many
tells you,
iterations it's doing, then you fill that in instead.
right, yes, exactly. If no one tells you 10 trip count's a good estimate. 8 because it's easy to shift by 3 if you have a compile speed issue. Which when I started Hotspot, that would, multiply by 10 versus 8 was interesting. Now, whatever. But yeah, and then if somebody comes along and tells you, and this iterates a million times, poof, presto, you got your number.
Yeah. And what do you do for the infinite loop?
It can be trivial. It can be treated as being extremely high. So in the case of the optimizer in general, infinite loops are problems because you can't reach them from below. There's no way out of the loop, so there's no way into the loop if I'm crawling up from the exit of the program. So I insert a bogus exit called the never taken branch, or the infinite loop branch, or however you want to call it, that looks like a branch, and I assign it a ludicrous branch frequency, but a non-zero ludicrous branch frequency. This exits one time in a billion, or whatever it's going to be. Right, and now it all looks like a standard program with no infinite loops, and everything else just maths out just fine from there. So it gets an infinite trip count, but it's probably not the innermost loop. So pretty soon you don't care because the guys inside all scale up. So you have to watch your overflow. So I don't actually give a 1,000,000,000 ratio. I think I gave it a 1,000,000,000 ratio on the exit path. And then floating point numbers said 1,000,000 was whatever 8 bits out of my double precision, whatever. So you could add some number of loop nesting depth and not run out of double precision overflow bits for frequencies. But everyone in the inner loops are obviously much higher than the outer loop of the infinite loop, and it all just masked out fine.
Okay. So that in that you said that you add a kind of bogus branch out of the infinite loop.
Yeah,
like kind of a type of thing.
Right.
But then does that live right through the whole compilation, or do you at some point toss it out?
No, it lives through the whole compilation. So in the SSA Sea of Nodes version, my if statements which exit a loop would have a conditional. I put the never taken conditional branch item there. That was a special constant node that said one time in a bajillion, true, otherwise false, whatever. Everyone else understood the frequencies that came out of that, but they didn't have to understand how this node produced its value. When it comes down to machine,
you basically have to have a sort of special false value or zero value that the dipole optimizer doesn't know is zero.
Yeah, exactly. Right. The optimizer treated as statistically very, very close to zero, but he wasn't sure. And then when it comes to instruction selection, it's just a regular jump with no conditional on it, because it's just jumping backwards as the infinite loop. So if I ended up producing a basic block, at the end of the basic block, there's a conditional on if. The conditional was the never taken. The instruction selector said, you're the hardware plain normal jump. For everyone else, you got to jump equal, jump less than, whatever it's going to be. This guy was like, you're just a plain jump. Excuse me.
I have a jump that's almost never taken.
If it's actually almost never taken, you have to have a jump, not my stupid unconditional. Sorry, go ahead.
I was trying to think how cheap it is if you're trying not to stress out the branch predictor.
Yeah.
And I want it to just be like, look, it's a forward jumps default to not taken. I've never seen it taken, so I don't have to put any garbage in I'm not consuming bandwidth in my
There's a very
predictor.
specific thing for bigger CPUs where they have branch target buffers or branch predictors, both. The specific thing is your tests, which rarely, if ever, never fail, such as all the Java safety checks, want to always fail going forwards because he'll predict the backwards branch is taken. So if he correctly predicts, then he will not, excuse me, he will not pollute the branch register, the branch predictor, who will put an entry in the branch predictor because he got it right with the default predictor. Okay, if you don't do that, you'll drown the branch predictor out, and he will be flooded with easy predict branches that happen to be laid out the wrong way for the default, and the hard to predict branches won't have space in the branch predictor, and they'll be taking the random potluck, and you'll get branch misses all over the place. So if you do what the default hardware predictor takes, you'll both yes, your unpredictable branches will have a chance to get hardware predicted, and they'll do much better. Okay. There was a second dumbass piece here, and I lost it in all that shenanigans. Fine, I don't know. Fine. Yeah, they're like, if it's not in the predictor table, he defaults to going not taken if it's forwards and taken if it's backwards. That's the other piece of that. So if you have a safety check, you want it to default not taken, which would be forward. So safety checks want to bunch forwards, and you have your handling for the failed safety check down the line. So it's just a little layout game when you do basic block layout, which Derek didn't talk about, but he's got to do basic block layout too. So you want to arrange that blocks that you think will branch one way or another are laid out in such a way that the branch instruction that does the prediction predicts default without having to remove anybody, without having to go into the target.
Yeah. What I've done so far is in my IR, I have at some point if statements become just a conditional and then two labels, and so I decide that I want one branch or the other to fall through rather than jump, and so I reverse the if condition if I need to, and then I mark the else instead of a go to. I mark it fall to this label.
Yeah. So in my particular IR, I kept everything in SSA all the time, but I would add things such as, and I'm the fall through or I'm not. When you come time to sort your basic blocks, pick them in frequency order as a sort by frequency if you're gonna just do the sort thing, and pick a guy who's most hot and decide that his fall through should be taken or not, because once he's laid out, the next guy gets forced, and the next guy. And so people with lower frequencies can be stuck where they must take a unpredicted branch, or they must have neither of their choice blocks fall after them. And so they have to conditional to one and unconditional to the other. So you want that to all happen on blocks that are cold and you don't care. So sort your basic blocks by frequency.
I can't picture a scenario where an if statement would not have a
Trust
direct
me,
fall.
it happens. So
Okay.
so I have a hot piece of code, and it wants to loop backwards. So this guy wants to fall off because he's the hot guy. I want him picked correctly. Now I have these two guys here. The guy at the bottom says, oh, I'm a nested irreducible loop, and I want to jump either to the first guy or into the middle of the second guy, both of which are backwards branches, neither of which I can fall into directly. So I must jump twice, once to the one and fall through, jump to the other. So the single basic block ends in two jump instructions, which looks like two basic blocks, but I don't want to split just to have an extra jump in there. Instead, I just omit the extra jump. So there's layout forcing that happens, and that's why I'm saying do the hot guys first so they're not forced. The later guys, some of them will get forced, and it's better to take the misprediction typically than the force the wrong way, but not always. Sometimes you actually want to keep the branch target buffer, the jump predictor, branch predictor table clear. So you predict an evil thing, and then the next guy has to be a bad jump, but you don't care because it's a cold block. And you're saving space in the branch predictor. I don't know if your guy has a branch predictor. He's small enough, he might not have a branch predictor.
No.
Okay, then it doesn't really matter for that particular layout game.
Yeah.
But you can be stuck with double jumps. So do the hot loops first. Make sure all loops
Okay.
get their chosen backwards, forwards branch.
Okay. I would love to see a piece of source code that actually produces a double jump, because I'm still having a hard time picturing it.
I got them all the time. The Lambda hotspot, Java. Well, you don't understand, but people throw and catch exceptions. Every time they throw and caught inside of a loop, because of the way the catch handling works and the compiler would optimize it to go to, I get irreducible loops. As soon as you're drowning in irreducible loops, you get all kind of horrific branch to branch to branch things that are just uglier than sin.
Okay, yeah.
You
So
probably
I'm
won't get
saving
that.
myself the trouble of the try catch for now.
Yes.
Although I thought maybe I'll do it. One thing I do have to, so one of the fun annoyances of Python is that you can return from anywhere.
Yeah.
So I have to somehow incorporate that.
You have a gather point that says this is the whole method return, and all the other returns that you've scattered, they just jump to the guy at the bottom. Then you hand this off to the optimizer, and a thing that's like the tail end splitting is a valid optimization where you look at the pile into the merge and then you just do return, and you say each of these pile ends, some of them I can split off and say I'm going to do tail clone and get a direct inline, do the epilogue and return, and not have the and get more optimized on this particular guy. If I know I have a hot return and I have a bunch of cold returns, the hot return I might tail split.
Yeah, okay.
I'm sorry, what is tail clone, tail split?
The general thing is I have a merge point which gets from a bunch of paths, some of which are very hot, like one is hot and the rest are kind of met. Then the code only goes a little ways and you're done with the method. So you take the hot guy and give him a private version so that the hot guy doesn't have to do the full semantics of a merge, which probably blows all registers and has to recompute whatever the tail recomputation is, followed by the epilogue code and get out. Instead, the hot guy says, well, I happen to know I'm hot because I'm an easy return of a 0 because it's your case of 0 as an algorithm gives me a quick answer. Okay, so I want the hot guy to say, before I save all my registers, test for 0, go to the general, unwind all my registers and get out. I want to say, I'm not blowing any registers yet, test for 0, oh, return. And instead of 5 stores, 5 loads, a test and a branch and a return, it's test and a return. And then everyone else pays 5 stores, 5 loads, and blah, 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 blah. So that's,
And if you're hot enough, that's a big win.
Yeah, right. Yeah. So the tail split is just the half of that, where I say, this exit is the default exit, it's the normal exit. It has a easy, cheesy path, and I don't want to do whatever everyone else is doing on the exit. I'm just gonna find an exit for you. Yeah.
I know I went this way. I only trashed 3 of the 5 registers. I only need to fix 3 of the 5 registers.
And if you're like a simple
Sweet.
enough guy and you have to do iCache prefetch manually yourself, having things in a row, the hardware will pre-cache for you. But if you took a jump, you probably lost something and you get a bubble in your iCache pipe. So no jump now, because you loop and the exit down and I'm done, and then the done code is right in line, it's good. Whereas the loop took the funny path out, then there's all, who knows, it's the low frequency, I do weird shit, and I don't care if I took a branch from this now, because that's the low frequency path. So
although deciding how hot it has to be to do that feels like the sort of black magic.
You can count
I have to pick a random heuristic here to make sure that the code bloat was worth it.
And you can dial a knob on that number, but you can also, in his case, you probably count cycles.
So would one strategy for doing this be to basically split out the tail into a continuation function and then make it a function call and do it like a inlining decision?
Okay, so let's break out outlining from what you just said, because what you basically said was outlining. So if you have only one chunk of code and everyone jumps to it, then it's basically being computed in the spot and you've inlined it, and you don't have to do any special prologue, epilogue things. The register allocator takes care of business. That's the normal way these exits are done. If you have a case where you see a complicated thing happening a lot of times, but with different inputs, there's a game that says, instead of repeating the code here, there, everywhere, I'm going to outline, and you invent a function where there wasn't one, and you send everyone off to the outline function. And this is typically done on small devices for code savings. It can, in theory, be a performance win if you're running an iCache out of iCache space on an x86 and you quit getting iCache misses. But in your case, you're going to live or die in your 8K, so it's not, I wouldn't outline manually.
Okay.
Make the user hand outline if it's going to outline. So if you have a bunch of exits and they go to some shared common thing and then they run it through, it's just one piece of code. They'll go to it and they just run it through.
Yeah, okay.
But
But it
you didn't
seems
save
like,
any space to take that body and wrap it in a function header.
yeah,
'Cause you
it
still have the
seems like-
body.
it seems like inlining and loop unrolling and then this tail
Split.
splitting
Yep.
is sort of very related.
Yeah, they all increase the count of code, the volume of code in exchange for knowing more about that code and then getting more optimization done on that code. You get a private specialized version of this code that you can do something with. In the case of like inlining getters and setters, the single load instruction in a getter removes the prologue epilogue, save the return address, reload it, jump, maybe load a register, store a register. Okay, gets rid of that. You have a single load. That's one op, one clock, one whatever. Probably there are other getters of the same thing. They probably can be commoned up. So a getter inlining might return each getter inline cost could be a fraction of a load instruction. Not even one load. If you inline 4 getters, it's a quarter of a, each one counted as a quarter of a load. So inlining small things is almost always a win, just straight up. As you get bigger and bigger, you have obviously iCache blowout, which is performance on an x86. For you, it's just like death. You can't inline too much and you're just dead. So there's a knob, and now the register allocator plays a major role in how hard you can turn that knob. For your small guy, I think you have your hard limit. So you probably want to keep the heuristic simple and pretty conservative, or else the compiler will come back and say, I inlined too much and then I died, and you'll have to come back through and no inlining keyword or something. You have to tell them. You have to.
Yeah, I've seen people using no inline, and having the existence of that keyword is something that I would like to avoid.
Okay. Well, it does
that?
mean shit like if you're doing partial compilation, you don't know if you took too much of the iCache space for the rest of the compilation that you're linking up against. If you do the whole thing all at once, you can look at the end and say, I blew it. And then you go tell the user, I'm sorry, it took 30 minutes and I blew it. I'm going to rerun with less inlining and I'll be another 30 minutes before I give an answer, right? Yeah. But you can,
Yeah.
Right. So you dial those knobs and you won't hit that situation very often. You probably also have a sort of a minimal code base, like the count of users of this is pretty small and they're not going to have super fast moving code in terms of code volume. They're not changing their code really fast. Some data scientist is picking out your algorithm. It's not moving super fast. Okay. You tune those knobs once, you'll quit blowing out your iCache and no one will care and be done. Like there's definitely diminishing returns here also. Inline that getter, that's always a win, often a nice tidy one. If I inline a generic large thing inside of a loop, the loop made it hot, but the generic large thing was way more expensive than the prologue epilogue, so it didn't necessarily give me a huge win.
And if you end up spilling more than you would have spilled to jump in, then you're lost.
Then you lose.
Right?
Yeah. So that's one of the things I did in Hotspot is I tried really hard, actually got successful at it, of not spilling more than the prologue epilogue if I hadn't inline, which meant that I didn't have the spill cost fail if I over inlined, which meant I could be a lot more aggressive on inlining without falling over the knee of the curve of the allocator failing.
Yeah.
In your small case, you probably don't have that such a worry.
Yeah. One thing I've seen, which seems a bit odd to me, is that when people talk about inlining, they put the bounds of the inline method into the sort of code where they inline it. So they're like, here's where I start inlining, and then here's some code, and I'm done inlining, and then we go on. But it seems like that screws you for instructions controlling.
Well, it screws you for many things. The major inlining gains are common sub-expression elimination, and so you're going to get these from all over the map, and loop invariant code motion.
Yeah.
You inline a hot inner loop of that big method. Turns out that 50% of it's loop invariant. you do get a big win if you haul that invariance up. So I don't ever have a line in the code where I said I start and I stopped inlining. I threw it into the graph IR, I wiped all those edges out. I have more graph now, and then I optimized
Yeah.
more graph.
Yeah, that seems like a better strategy.
Yeah.
And if you need to go back, then just save the old graph, I guess, first.
If you have to unwind, yeah, I would if you over inlined and you ran something out, I would restart and say, try again without inlining this guy. So
Oh,
there were
really?
there were plenty of heuristics that came out in Hotspot that don't necessarily apply in your case, but there's a lot of shit like, if I inline this guy, it turned out not to be a win, and I had a lot of frequency data, so I could say stuff like, it's a big method, and a bunch of other people want to call it, and if I inline a big method a bunch of times, it's like, oh, CUR, it's like not necessarily a win because I blow my iCache out. So there was a threshold where I said, don't bother to inline a big method that's already himself been inlined into, and so that's how his generated code got big, because he got inlined into already. And I don't know, you're in that spot, but there was definitely heuristics that said, 5 people call this modest size thing, I can inline modest size 5 times, or I could just leave it a function and have only 1 copy instead of 5 copies. Little guys, cheaper to inline every time. You got less code, there's always a win. Medium size, you had to watch how many people were going to inline it. Big guys, never win unless you're looking for that inner loop invariant code motion hack game.
Yeah.
And
is
that finite levels of inlining, I guess, also stops you from getting into some deep loop. If I put like factorial of 1,000 in my code, and then it does constant propagation, in theory, you could constant propagate that all the way out, but you're doing 1,000 inlinings and 1,000 constant propagations.
Recursion had its own heuristics that said, I am recursively inlining. That's a version of loop unrolling, and that went under the loop unrolling heuristics instead of the inlining heuristics. Yeah, so I looked, and if I saw you come back around again, then I flipped over to the you're now inlining, you're now loop unrolling. So yeah, you got a much tighter cutoff. The productive gain for continuing inlining was not worth it. Yeah.
GCC has some aggressive optimizations in their loop unroll.
I did a thing where I unrolled once, took the odd case because you got an even odd split on the unroll, put that in a pre-loop. So I took the loop, I made a pre and a post amble. Pre and post amble covered range checks, over and overflow issues. The center had no range checks. Okay, great. The pre-loop covered all the null checks if things are going to get null tested. So the inner loop had no null checks either. Typically, if you're just like a 4 trainee, do some array math, you shrank really big. So I unrolled you, and then I looked again how big you were. I put the odd case in the preamble and then carried on. If you optimized back down, I enrolled you again. So I kept doubling you until you got big enough. What that meant was, for people who did like 4 training things, you typically unrolled 4 to 8, maybe 16 times. And then I aligned all the loads in the stores to be pleasantly cache line friendly, and you got what you get out of BLAS for standard straight up. I'm just doing a single array thing. If you doing micro benchmarks where you did your factorial of whatever, but it wasn't factorial, it was some other stupid thing where they were, I don't know, counting or multiplying, summing numbers from 1 to 10 or whatever. I basically unrolled you by powers of 2, and you had a logarithmic solution. So you could have a, sum of a billion, and I just did powers of 2 on you. And so in log of a billion, I got your answer. So when people run these micro benchmark wars and they go ask Hotspot what the time was, I computed this number for 1,000, for 10,000. They kept up powers of 10 up to a billion, whatever. The answer was, well, you ran 10,000 iterations in the interpreter. You compiled for 10 milliseconds. You got an answer computed in 5 nanos or 20 nanos. So independent of trip count, your answer was, 10,000 in the interpreter. That was 10 millis. 10 millis in the compiler, and done. And that blew up everyone's, I'm doing a micro benchmark to see how fast you are numbers, because they couldn't understand the numbers.
I tripped across that once, that I did something and it was like, oh, the output of the work you're doing that you're trying to time isn't used. So that's all dead, which means you just have a loop that counts to this number and replaced it with the closed form solution to that count.
I did that
And
on
it was like,
several easy
5 nanos,
corresponding-
I multiplied n times n minus 1 and divided by 2. And I was like,
Yep.
I mean, you're not wrong.
Yep. Yep. I
I didn't
beat
actually do
several
anything with the
micro-benchmark
output of my
people that
benchmark.
with-
So
Yep. That was a fun micro benchmark wars era. You know, it was a decade of that where I had to tell people how the hell jitting works. They didn't understand. The answer was 20 millis, and here's your answer. And it didn't matter how many trips you did. It's 20 millis, fixed time. 10 of the interpreter, 10 of the JIT, and your answer. A lot of broken tests came out of that.
benchmarking's hard.
Yeah. It actually, yeah. So we had people do shit like, I'm going to run this and count iterations in 1 second, decide how many iterations I need to run to get a reasonable answer after that. And of course, they would interpret for some amount of time, and then they would JIT some amount of time, and then they'd run JIT at a little bit of time, and they'd say, I need to run X iterations. So then they'd come through and run X iterations in the JITted code only, which would be too short to measure. And it was Windows, so you had 10 millisecond resolution out of the damn Windows time room back in that era. So you got a random number from 1 to 10 millis as your answer. I ran it for a second, and my answer is between 1 and 10 millis at random. And of course, they would report the first number that came back, which was a number between 1 and 10 millis. And then they divided it by their trip count and come up with some giant ass number, except that every other person who ran the same test got a different giant ass number based on the divide by 1 through 10. So fine. This is fun with micro benchmarks.
That's why we end up with benchmarks that are like, go compile the Linux source code.
Yeah, honestly, you know, I lived through that era where everyone they're selling their hardware, or my hardware's faster than yours, so based on my benchmark versus your benchmark on yours, right? And so benchmark standardization wars, and then the early benchmarks were full of crap, and then, you know, those
Wait,
got,
Sun cared about hardware?
Yes, absolutely. They were selling
Not
against,
not
yeah, you'll have,
performance, but they cared about selling hardware.
they were selling against IBM. That was my salary, was coming from them selling hardware. So I was tasked with beat IBM.
I assume the JVM still runs on the IBM 360.
Oh, I'm sure it does. IBM would not have.
It's a
turned out.
390 now, or a Z whatever, but yeah.
Yeah, Z whatever. Last I heard, I don't know. Yeah, but like power chips, right? And so I'm sure they have a mode that says, don't look like an IBM 360 instruction set, look like a power chip, and go to town as a power chip, and it's probably pretty good. Yeah, these days they might have even bailed on that and said, oh, you're a JVM? We're going to run you on our x86 we stuck off as a wart on the side of the Z390 or whatever.
Anyone mind if I change the topic completely?
Please.
So one of the patterns I see all the time is at the very edge of my system, I take in something that's super generic. It's like, you gave me a JSON object and I decoded it, and it's some kind of JSON value. And I've got a bunch of schemas that the thing has to meet. And I often end up in this land of like, I have all of my types twice, because I have my types as defined in the schema validation thing, and I have my types as defined in the programming language. So if you have something like AA that's going through and doing all of this inference and building types, and I understand everything that got called on everything, but I want to push all of that back out to the perimeter and say, okay, I'm decoding this JSON thing. I'm about to pass it through all of this AA code. I want to know, before I actually pass it through all of this AA code,
Right.
that it is in fact the type that is the type that these things take.
Oh,
Is there a way to get the validation types and the core language types closer?
This is like loosely related to reflection-based serialization. I want to take the types of your schema that AA is using and reflect it backwards to an algorithm which will take a JSON and validate that it's that type.
Yeah, that.
I totally am in the zone of, I can hand you reflective types in AA as a, I know that's part and parcel of my design theory anyhow. So I should be able to.
At which point you want to know, does the JSON conforms to a type?
before I begin doing typey thing, well, before I move it into an AA object, like I have a JSON, I have a string. It's a JSON. You tell me it's a JSON string. Okay, fine. I have an AA type set. I want to move this string into this AA type. I want to import a DOM object or whatever the fuck, right?
You want to deserialize it to
Yeah.
the non-AA object.
From JSON serialized to a known AA type. Okay. I claim I can take the known AA type and produce it as a reflectively visible version of structures, reflection of structures that describe the type.
At this point, you have to check.
Somebody can now take that and have a generic string to type checker that parses the JSON string, validates this type, and then fills in the object. And that sounds like a useful thing to throw in a JSON parse library.
Yeah.
I kind of sort of did that with H2O. I had a known Java type, and I produced a serializer deserializer pair, but the deserializer would read something off the wire and know to stuff it into the Java object as it went, as part of the generated code. I mean, it produced bytecodes to do this. It didn't do checking because it was only being produced by the serializer, so I didn't have to check for it, but I could have thrown checks into that.
The tricky thing is if you have to check at runtime, you always get something like an option of an T of the type you're relying, or or a null or something that can.
Yeah, you get a response back saying it's okay, and it's this type, or it's an error, and here's the point where it failed to meet the spec.
Yeah, the dependency, you have to thread this for the constant checking of an options.
No, I think that's fair.
Preferably even with two flavors of error. One error that says, here's my deep understanding of your code. Because you have this line of code at this spot, your object doesn't match it. And you also probably want to have a kind of blinded error that's like, just hand me a thing I can hand back to the user that says,
the first thing
I expected lat long to be two pair of numbers, and you gave me a lat long that was a string and a list, and I'm like, that is not a lat long. Here's my description of what a lat long should look like.
There's semantics and there's syntax, and I claim that we can do the syntax piece automatically with an error report, but what you get back isn't necessarily have all the invariants that you want. You have yet to go do your semantic analysis of what you got back.
The first thing that Aaron said qualifies as an option. You have an object with a bunch of fields, and in the end, you either have something or you doesn't have something. The second thing is either that can compose, that can, at each point, if you give an error, that can hand you this field cannot be converted to this type.
Age can't be negative number.
Yeah, or something like that.
Right.
But so if I have validation baked into the constructor process and I blow the validation, at what point do I stop and give you back an error? Or do you want all the errors I ever found? Here's 1 million people, 10 of them have negative ages and all the rest are fine. Do I want to stop and blow up or give up, or just want to say, I got 990 people and this is good enough to go forward progress with, and the other 10 I'm going to claim don't make it, and here's why.
Do you fail fast, or you report?
Or do you go to the end and collect them all? And I do H2O during big data. I read these giant terabyte CSV files. You didn't fail fast. You went to the end, took it all. You reported failures and you kicked them out. I didn't get 1 trillion rows. I only got 1 trillion minus 1 million rows. That was well good enough to go do, the next step of things.
Right. The other pattern I see is I end up with like 2 identical trees that have to be kept in sync with each other. It's like, here's the shape for the validation and here's the actual code. It would be nice if I could pass this into a function that passes into a function that passes into a function, and then I have my validate statement deep inside a nested thing that says, by the way, this lat long, like one of these numbers better be between 90 and negative 90, and the other better be between 100 and negative 180.
Right.
But even though that assertion is deeply nested inside my code, I would like that to propagate all the way out to my line of code at the very beginning that says, can I conform to this spec?
Right.
That's what I
But
said.
it's weird because that code lives deeply nested inside functions.
The compiler have to have an ability to move the checks right at the beginning. If you fail immediately, not in the middle of the code.
I think there's an API for this somewhere in the universe. Like the reflective types to go make a JSON parser, followed by you hand me something which has a validate Boolean function that validates. And I will build you this object according to the deserializer, and then I'll call validate. And if it fails, then I'll reject up to whatever point you say the validation failed. If my subparts fail validation, I fail, or I can chop out subparts that fail validation, whatever. There's something else about concatenating failed validations you have to sort out yet. But then I hand you back a thing which says, here's your collection. Here's the separate collection of things that failed validation, but your validate code goes on the object description, the class description for what it means to validate a deserialized thing. And the actual deserialization.
Yeah, if I can just stick my validators into my class, that solves a lot of this problem, because my validator can decide what to do with its nested validators, whether to fail on fail or collect errors and pass them on.
You have to decide, if you're a collection of things that can fail validation, you have to decide what parts of the collection you keep and what parts you toss. Like you might say, I took the lat long and you gave me crappy, so I'm going to swap it out for nans. And this particular data point doesn't have a lat long, but maybe I don't care. I'll carry it through anyhow. And there's another one.
It sounds like your argument is that you can build this in the standard library. It doesn't have to be a language feature.
I think I can build it in the standard library, where you need a validate call. If you want to call the JSON deserializer with validation, you have to implement a validate call on everybody who's referred to in the JSON deserializer. Like the top level guy, JSON, the top level AA object, which supports deserialization, has a validate or not, and then you can say, please reverse this and give me one of these top level guys. And if you have a validate and you call the JSON validator version, he validates. And if you call him without having a validate, you get a compile time type error saying you didn't have a validate function here. And if you ask for just give me JSON without validation, that's the same thing. I'll just call the null validator on you or whatever. I'll just skip the validation.
Right. If you have a thing that takes a well-structured object and I pass you a JSON value, then it's just gonna be like, this function's not defined for JSON value. Bye.
I think I can put a reasonable JSON deserializer. Now this JSON deserializer only works, and if you do the automatic type one, it only works for JSON of a particular shape. Like the field names in the class you're making match the field names in the JSON, right? And if the class you're getting has a string field, I'm expecting a JSON string. If the class is expecting ints and floats, I'm expecting JSON ints and floats and shit like that, right?
Well, JSON floats.
Yeah, but nan versus not the nan, I think everyone just agrees that you can throw a nan in a float field and just live with it. Hey, Dan, see ya.
So that begs the question, do you have a sense of what a good API is for that reflection? If I have a type that AA has inferred a lot of things about, and now I want to do something like, can you print this type for me? Or I would like to reflect against that and take action on it.
Here's a string version of the type. So you can pretty print a string or something.
So like, what kind of data structure should I get back when I say, hey, please give me the thing that describes this type reflector?
I don't know. So I don't have an API in mind. The current API I have is, I'll give you a well-formed string version for which I have a reversible parse. I give you a bidirectional parsing string variation. Now, if you want to do something fancy, like build a JSON deserializer from a string version of type, you have to parse the fucking type the way I parse the fucking type for the type string. So maybe you'd rather have like, it's a type, so you kind of can get an AST. I have sharing, you get a DAG. I have cycles, you get a cyclic graph. I can hand you a type data structure, which is a cyclic graph that represents the type. And you just have to live with walking this particular data structure and doing what you're going to do to build a JSON parser off of it. Maybe that's the right answer. And then obviously a string pretty printer on that's pretty easy. You walk it with a
the thing about I give you a string that turns back into the object is a little tricky, because there are some objects that don't have permission to disclose internal state.
No, if you ask for a type and there are privacy things going on, then the type will exclude the privacy things, but you can't write a deserializer either.
So if I say, here's my encryptor, and it's a closure over a public and private key,
Yeah.
Okay.
And then I say, great, hey, reflector, give me a thing that remakes my encryptor decryptor.
But you.
No,
It can
but-
totally hand
Just to be
me,
clear, if you have a
here are
public
my
and
two
private
functions,
key,
and here's my public key, but it can't give me the private key. Like,
I think
No.
if you already have the private key somewhere that you can access, you've already made a
Mm.
mistake. So.
but that's what I'm saying. There's objects where I can call encrypt on this object and I can call decrypt on this object, but I can't call serialize on this object because it is incapable of turning itself into a string that can be turned back into the
Yeah, yeah,
object
I
because it
understand.
can't
I've
tell me
seen-
the key that it must know to exist.
I've seen the ugliness that's Java did in that area, for example, to pretend to hide the keys. Yeah, but I'm not saying that's a good design to emulate.
Right. The game you're playing here is I have a thing with secret keys. I want to serialize it. The key ends up in the serialized form. I read this
Of
key out of the
course.
string that I got serialized.
Yeah.
Right. If I'm a closure over state
Yeah.
that is not public state,
Mhm.
then I can't serialize. That is simply an unserializable object.
Okay.
The serialization.
But public, private, protected is not a security mechanism, and pretending it is has cost many companies billions of dollars. We should not go there.
No, but closed over is a security mechanism.
Mm,
No, it's not. It's,
mm,
it's another way of hiding information. It's
Yeah.
it's as bad.
the main point is that JSON is a pure data. It doesn't need to when you construct a class, you have to construct it from the data. It doesn't have to contain anything like that
Think
can.
of it like ring 3. I'm agreeing with Tidor here, but think of it like ring 3 and ring 0. If you put something in ring 3, dude, just put it in the mail and send it to a hacker directly. Like, if you put something in ring 3, it's there. Any piece of code that is executing can see it. Now, I'm not going to say that anyone can write the code to see it, but it's there. It's plain text in memory. Go get it.
Short of breaking the security model in the hardware by doing meltdown or Spectre, it's not available unless it escapes your privacy.
No, but I'm saying it's in ring 3. It's in your process space is what I'm saying.
Okay. So if
Sorry.
it's in a process space, but in a private field, how much security would we expect? Assuming I'm not doing
None.
any Spectre meltdown. And you say
Zero.
none, why?
Because there is none. Because
Why?
I know what assembly looks like.
Okay, so I'm not running arbitrary assembly. Now, as soon as I call
Right.
native
I
power-
have to JIT you. If
Yeah.
you want to run something, you got to make it through the eval, and I'm not going to build you an arbitrary assembly object. I'm only going to build the things that eval is willing to build.
Eval doesn't have to be allowed access
And
either.
you're going to take away the ability to execute a command line. Like, are you going to take away system or system.execute or whatever? Like, the point is, if there's
Frequently.
any surface area that's reachable that lets me run arbitrary code, whatever's in my memory space is available to me to read and write. Period.
No, that's
Yeah.
the whole point of closures.
No, you just attach
You-
a debugger.
But
Really, attach a debugger. You read and write it. I mean, the
Okay.
hard part is finding the memory address. And
Yeah, so if somebody runs your process from the outside, launching on a debugger, you've lost already. The external guy has said, I'm going to peek at you. If somebody on the outside says, I own this box, I can look inside of it, you've lost already. I know what it is. If I want to have a key in my accessible to your private key that I can then do security things with, if anyone has access to my physical hardware sitting next to me on my floor on my desk, I've lost already.
That's true. And that's what VAX taught us, is that there were no security holes in VAX unless you had access to the machine itself.
Right,
Right.
right.
Going
Yeah, that's what I'm
back to
saying.
1980, right?
You
Like,
can,
so
in
I'm not talking
theory-
physical.
in theory, you're still supposed to alleviate this with the trusted execution environment like ARM Trust Zone or Intel SGX. But note that SGX is known for a side channel a month.
Yeah.
So,
So like I said, ignoring the failures in the hardware via like Spectre meltdown, I assume also as part of my trusted computing base that my OS is nice and polite and not sending my.
Right, but that's
CPUs to Microsoft.
OS. You can never trust your language, though, is my point. The language has no control over the OS or over the memory, or like the
I-
language is powerless to defend. And the important thing is that
Yes.
security by obscurity has a different name. Security by obscurity should be known as wide open.
So back. I mean, I'm gonna respectfully disagree that the current state of the universe is I have to trust my OS as part of my trusted computing base. Once
Yes,
I trust my
OS, I got you. OS,
okay,
yep.
once I trust my OS, I can trust my process because I know what went in it. So if in this case, I'm going to say I'm going to trust the JVM to not reveal secrets. And now, of course, the JVM is a Java, they blew it, reflection. Okay, so fine. So if I threw reflection out of Java and I had a private field, there isn't a way to get at it. Certainly I could define a language. There's not a way to get at it without going outside of the language. As soon as I go outside the language is powerless.
But Java has, right. But again, Java has surface area that lets you write a file and then execute it.
Right. So when you're
Yes,
evaling
but
untrusted code, you don't give it that credential.
No, hang on. Java, write a file and execute it means I have to pass the validator. If the validator lets me get at my private fields, then there's a fuck up. If it doesn't, then I'm still safe. I can run arbitrary code in Java without blowing up. And that was one of its main claims to fame, remains one of its main claims to fame. I read somebody else's random crappy code. I ran it. It didn't break my security because the sandbox was complete up until reflection blew it.
But we are talking about in the context of reflection. You have to get information from outside and you have to be able to read it. But that happens some points. Some fields are private in there. How can you restrict?
Okay,
That's what I'm saying.
So now we can
reflection shouldn't pierce a closure.
Yes. So you can have a version of reflection which does not pierce the privacy.
But this puts the constraint to the serialization to somehow blob it, to somehow.
Because if you are allowed to serialize the private key, then yes, Cameron's absolutely right. I'll just print the private key out to scan it out in my serializer and I'm done. You know, what the fuck? So if reflection can't get at the private fields, it can't serialize them and it can't reveal them. So you keep the security and you lost the ability to serialize your private keys.
Think about how an OS would prevent you from getting to its private keys. It doesn't put them into your process space. That's the point. You syscall and they're hidden behind a syscall, right? Yes. Am I forgetting anything?
No.
So my point to Aaron, and I totally get where Aaron's coming from, but my point is the way you prevent something from leaking isn't by labeling it private and hoping a compiler cooperates with you. It's by not putting it into the process space.
You have invented a border called a process space boundary, but same borders can be invented in many other ways by many other people and have been all throughout the years of computing history. Some of those borders were not
but
ever
in C++, all I need to do is cast it to void star and there's no border.
Then
this language isn't C++.
Yeah, C++ doesn't have a tight border.
A middle ground.
You can make a process, you can make a language with a tight opaque border. C++ is not that language. Java happens to not be that language because they blew reflection.
A middle ground can be if you send the parts in with the JSON that has a private fields, the part of the serialization library is to encrypt it and to decrypt it on the other end as privates, but that would be tricky.
Yes, because you have to agree on the key that the JSON's the serializing.
You have
already have the
encryption library inside your encryption library if you send the keys.
98% of the 98%, and I'm making the number up, so it's probably 97 or 99, but almost all the security bugs in Java come from a tiny percentage of the features in Java. RMI, serialization, and servlet. Like
there's
servlet, applet or whatever. Exactly. I mean, but it's like a tiny portion of the language.
I claim these can be fixed. And you can have a hard wall that you can't peek through, short of breaking it from the outside. Like,
there is an interesting paper about it in the .NET context called Securing the .NET Programming Model. And essentially it references the so-called concept of fully abstract compilation, which is the compilation that would disallow you to distinguish anything from the source language level at the target language level. So for example, this is what is broken in C++, because in C++, even though if you even imagine that the public and private worked, then the target level assembly would still allow you to distinguish the private data from the public. So this is broken for most mainstream languages, including Java and C#. And this paper is nice in that it shows you example after example of how it is broken. So for example, in C#, it's broken by boxing and unboxing feature of the language, because you can expose the interior pointer to the object and modify the data through that. And there is example after example. So this is even in safe languages like JVM. Securing the .NET programming model. I can also
I want to see how this breaks for Java without using security or native code. Like if I call it native code, I've lost my security. Right.
Right. But you should only be able to call native code from unsafe eval, not from normal eval.
Yeah, right. Right. Any eval that I declared I didn't trust has to not be able to call native code, or only calls what I would consider trusted native. I can do.
And I didn't get to say some very important part of what I was trying to get at, which is serialization is hardwired into Java because there was no way they could write it with the security constraints that the Java model had. So the security, the whole serialization thing goes around the security to do its work, because the private stuff would otherwise be hidden from it. And if you take that capability away, then suddenly 99% of the value of serialization gets castrated. I mean, I'm using that word in a technical sense.
What I heard
I mean, Rust has an unsafe library. Like,
okay,
I'm not saying you shouldn't have an unsafe library. I'm saying you shouldn't let untrusted code call it.
I have a middle ground here. Private is useful as a programming concept to allow me to write large, complicated programs where other people don't care what I do. Separately, I have security things, and in that case, I would like to be able to serialize my private guys. Separately, I have some security things like private keys that I don't want you to ever serialize. That's a giant security hole. Okay, I don't want you to do that, but I don't have everything on the planet have to choose between not serialized and not private. So suppose there's another thing that says, this is a secure field. Thou shalt not serialize this guy in any context, as amongst other things, including it'll be private as well. And now I can serialize private methods where private data where it's just private for abstraction purposes. But if I have a secure key in here, I cannot serialize you. You have to pass that key to the other guy some other way. The serialization library is a bad way to try and pass a secure key between two people. Does that make sense?
Yeah.
Tell me I'm wrong.
No, I don't. It's not a question of being, nobody said anything wrong yet. That's the point. It's about how do you approach the concept of security, and then that approach is going to dictate, what the attacks available are against it. And I think that's. I'm pretty sure Alan was vigorously agreeing with me on that topic. But but there's no such thing as perfectly secure, right? So it's more that you want a simple enough security model that you really have to work to defeat it yourself, right? Like you'd have to work
right,
to do.
But I'm trying to do more than one thing. So on the one hand, I'm trying to do least privilege. I want most of my functions to operate with as little power as they need to do the work that they need to get it done. And on the second hand, I want to have some borders that are really hard to pierce. And if I say I want every little thunk of code that calls anything else to do message passing and put a separate process around everything, my performance is going to be terrible because everything's in 40,000 processes, if not 40 million processes.
Right.
But the flip side of that is if I put everything in a small number of processes and just say everyone can read everything, I'm get very far away from principle of least privilege. So if I can have a bunch of closures that are lightweight isolates that give me a lot of security, but could potentially be pierced by a Spectre meltdown type thing. And then I have some stuff that's marked as secure that my compiler knows I have to use whatever special don't get Spectre and meltdown instructions are going to appear in the near future.
I would ignore.
And then I have something
Spectre
that's super
meltdown.
hard that says, okay, put this actually in a different process and flush all the buffers and totally change context every time you change processes.
So it took me a couple hours reading through the Spectre and meltdown papers to actually understand them. And, I've been doing assembly for 40 years. So I the people that came up with those attacks are brilliant in ways I can only wish to imagine, right? Like just so far beyond me, I'm not going to pretend, right? They're brilliant. But here's the thing, you don't want application developers to have to understand spectrum meltdown, right? Because
either they understand they can't do anything about it because
Yeah,
it's embedded
I only
in
want them to
each
understand
protocol.
this is a private key. I need to mark it as no for serious. Don't leak this one.
So,
Right.
so we came up with a solution for this problem, which is the container model that we have. But I'm not suggesting it's the only solution or the best solution. I'm just saying this was definitely a problem that we were trying to tackle. And the idea was, don't put the private key into the container. If the container has to be able to encrypt something, you give it an API that you inject in there where it can say, please encrypt this for me. And then that API is the portal through, that's the wormhole, if you will, from a physics point of
Right.
view, through which, and a wormhole is theoretically can only be basically an atom or a molecule in size. I mean, because the energy it takes to increase the size of the wormhole is almost infinite, right? So it's like
Stop with the analogy.
the
It's not helping here.
tiniest little hole possible, right? The tiniest little hole
Right.
is like this particular function I'm letting you call, right? And it's a type safe function, and none of the classes are visible through it. Only the actual
I
function
claim that's the
interfaces itself.
same kind of wall you should be able to get out of a closure with private state. That is no better and no worse than the wall I can get out of a closure with private state. You know, I have to agree that no one can, the closure has to agree to not leak it itself, including not allowing serializer that's been acted upon it to leak it itself.
So you're basically saying your closure should not allow reflection.
They yes, they and they will not. They do not. That's
And
that's the
because I have use cases for closures having reflection.
when I say they will not, what I mean is you can do anything to a closure that you can do in normal code. You know, anything with reflection you do with normal code. If I can't see the private field, I can't see it via reflection either, and then I can't serialize it. And so having that discussion, that's like too strict. Now I want a version that says, I'm not going to let you peek at private fields unless you're the serializer. So that's not secure, but it's convenient. And the private field goes from that cannot peek at it at all to it's a nice way to have encapsulation to keep people from understanding or relying on details I don't want them to rely on. Fuck it, they can look at the serialized version, read out the private data, and depend on the private data. That's bad on you if you want to do that. Then I need a thing that really is private, and that becomes maybe secure, and then there's serialized reflection doesn't work on that. No, serialization doesn't work on that. Now we have a discussion about whether or not serialization gets a special version of reflection that can see private fields versus a normal reflection which can't see private fields or not. And that's
my concern is you're kind of going down the same path of mistakes that they made in Java serialization.
Okay.
I may be wrong, but that's my concern.
Yeah. Okay. What's the I don't like a double depth serializer versus not. And
right. Exactly. Well, that's the first one is carving out the special permissions and this guy is allowed to do something that's illegal otherwise.
Right.
That's the one that tends to get you into huge trouble down the line, because even if you're right with the design, what ends up happening is you have a piece of code that's almost completely non-tested because there's only one client, so to speak, for that
serializer is the only
code path. Exactly. And that causes all sorts of quality problems. But again, that's just without understanding your full design, that's just my 2 cents.
Well, most of the design's in my head, so it's not full anyhow. I'm making it up as I go along, so it's all good.
If I have
that's
to
the point of these discussions anyhow, is to get me to
right.
attention.
But if you have a concept of unsafe and say, all right, I have a whole security model in my language.
Yeah.
If I use the unsafe library, I can turn this pointer into an integer.
Yeah, right. So I don't
and
have a
I can add
unsafe.
something to it, and I can turn it back into a pointer.
Right. So I don't have a concept of unsafe.
Don't you think you need a concept of unsafe so people can write drivers in AA?
No.
Where they really have to I specifically need this in this memory segment so that I can call this syscall.
Wants to do, I have to have a foreign function interface. As soon as I say FFI, then you have a security, your trusted computing base includes FFI. If the FFI cheats on you, it cheats on you, and that's just the end of the world for you. You know, that's your bad. So I don't need an unsafe, except maybe you want a convenient way to do FFI. But I'm claiming, you know, the first thing is I have to have FFI. If you are cheating on FFI, you're cheating. If I have to have unsafe, then if you cheat on unsafe, you cheat, and the rules go down the tubes, and that's what happens if you cheat yourself. So what I can say is you have a way to pick somebody else's code that you don't trust and run it. That code will not be able to unsafe you. Right. And now how do we enforce that one? That's the question. So if I instead say it's FFI, that guy can't run FFI code. You can hand him some FFI code for him to call because you need FFI to go do like file IO and shit. But he doesn't get to pick arbitrary FFI that he's named to go run. So you can hand him trusted FFI code. Now, can I hand him trusted unsafe? Well, reflection was a way to hand him trusted unsafe. Up to a point, like reflection lets you look without modifying values or types. And so
frankly, closing over it is how I want to hand people access to the FFI. I have some foreign-y thing like file open.
Right.
And I want to pass into a piece of untrusted code. You have the right to talk to this one file.
Right.
Great.
So
I'm going to make a closure that opens the one file and hand you that
There's a
closure.
version that says it's all the fields are secure, not just private, but secure. I don't know what private versus secure means here. They're all more tight. I can hand that off to this guy. He has a function wad in his hand. He immediately calls reflection on it and gets told all its contents are secure. You can't look at them.
Why is that better than just reflection can't pierce closure?
So I don't know. The reflection goal in my head was all the things that people do where you're willing to put them in your trusted computing base. So I want to have a version that says, I want to do something cool like I got out of all my JavaScript games where people did MobX and React, and they did state management to DOM update for me by handing them some piece of code that was interesting and complicated application specific and had them map that to an incremental DOM update on my web page. Okay, that required them to do reflective games. Okay, I want to say you're allowed to do reflective games here. There's a separate version that says, I'm going to hand you a function and I don't trust you worth a damn. So I want to limit what you can do with the thing that I hand you. So I hand you an object. Immediately you go after it with whatever toolbox you're given to tear it apart. But you're stuck because I am a trusted OS, so you didn't get outside the OS in the first place. And I only handed you trusted computing-based things, so you didn't start with a Spectre and Meltdown in hand or whatever. What can you do? Well, I want to say there is a way to easily make a box that they can't peek inside, like Cameron Services, that looks like reflection didn't work here, and it came back with this box is not reflectable. And that's the goal. You know, so there's two goals here, and one of them is it's secure, and one of them is it's convenient to do abstraction over and have private parts, but sometimes I want to invoke tools that break that privacy, like the debugger. And now I want to say, yeah, you want to go there, you can go there, I trust you. So that's the dividing pieces I'm hearing.
And if you're not running in debug mode, you can't do the debugger.
Yeah, something like that's going on. Yeah, the debug mode is an outside the process. God said, I am allowed to peek at you. You can't do anything about it. Oh, you're going to get peeked at. Fine. If I hand you something, I control up to the limits of whatever God let me control. When I handed it off, I said, thou cannot peek. So, you know, you can call this function and nothing else.
Yeah, if the debug mode is not, I'm deep inside main and started debugging, but
Yeah.
Debugger called main. Well, debugger called main, like.
You're done. Yeah, the debuggers, I'm the trusted computing and I do whatever the hell I want with you. Yep. Yeah, but if main called debugger, then there should be a way to limit what that debugger can then do.
We used to have these things called integrated circuit emulators.
Yes.
And those were our debuggers.
Yes.
So
right. If you're simulating the chip, you can see everything.
Yep.
Yep. That is exactly the point.
Yeah. So I think there's a way to do this with closures. And with and now that you've talked me into it, there's probably some multiple layers. There's a secure layer of reflection that has to be done, and then there's a convenience layer of reflection, and they're different. And
If I would do it, I would just encrypt them and decrypt them on the other hand.
well, the problem with the
What's the
encryption
problem
is-
with your key? It's
Yeah.
okay, encrypted, decrypted, what? You still need a key that's protected.
But this is not this. I would treat it like at the startup, you generate and you talk and you come up with somehow.
security has to start at the start.
No,
Right. So if
And-
I just want to put out a public library that does something useful like compute Mandelbrot's or whatever the fuck, there's no security thrown in there by my end to pass off to you. But yeah, if I want to open up a secure channel between A and B, then I need a key and you need a key and we need to agree on that key. Somehow we got them. Okay. Then there's a case if I want to take my secure channel and serialize it to disk and then deserialize it later and restart the channel. Well, gee, I just wrote the key to disk. In some
I don't
easy
think it
manner.
will. I don't think we need to serialize the state of the security. You
So
at
on
each
Amazon, I'm going to move you from one node to another. I'm going to
That's-
take your memory process space, serialize it somehow, and re-inflate it over there. But now you put Amazon's entire networking on your trusted computing base.
Right.
Oh yeah.
Ah,
Azure, AWS, and Google Cloud all will move you to a new physical box without closing your open file handles.
Yep.
Like
they'll-
that is a
Okay.
thing.
Yep.
Okay, that's fine. I will reinitiate the
So let me put it another way.
contract.
Google has
Mm-hmm.
the hardware you're running on. You got no security to Google or Amazon.
Yeah.
They can be running you on custom x86 chips that expose everything, custom OSs that let them peek and poke every piece of data on the planet.
But not
On
if it's
Amazon, you
encrypted.
trusted Amazon. But
If
maybe
it's
you don't.
encrypted, and part of your runtime, then they cannot read the state.
Up until you want to do something with it, if it's encrypted and just sits there as a black
So
box,
when
that's
yeah,
storage.
the moment
is
the
okay.
moment you decrypt it, yeah, it's vulnerable to the
Right, right.
system.
You can use Amazon for storage as you keep the key and hand them encrypted bits and you get back
Yeah.
encrypted bits and you decrypt. You kept the key, Amazon didn't have the key.
Mm,
You wanted to run the process, it got decrypted to machine code at least. They had the machine code in their hot little hands. They do whatever the hell they want with it.
we have to trust somebody, at least the AWS.
Yeah, right. Right. I'm not saying that. I'm saying, you know,
Hmm.
if you're gonna blow your trust, decide what's in your trust and what's not in your trust, and how you want to slice and dice the trust thing.
I would say it's a middle ground to encrypt your closure, so no one can pre-treat, no matter if it's FFI, it's in encrypted state. And when you set it, you decrypt it to enter your part of your program, and then you can use your private how you would use it on the other machine. That's way the state.
Okay, what I heard was I have some encrypted state that's like a
Yeah.
storage thing.
Let's say-
inhaled the state.
all of your private data comes encrypted on the other side.
To do that would mean the two sides agreed ahead of time how they're going to
Of
pass
course.
encrypted data back and forth.
And
Yeah.
they can use some sort of Diffie-Hellman encryption and blah 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 and blah blah blah.
Yeah, and then I claim that you can just make your closures use private instead of secure because your goal is to serialize them with the default serializer. The other version, of course, you wrote your own serializer that your closure cooperated with your own serializer. And you know, you did it yourself. Oh, you did it yourself. It's fine.
Yeah, yeah.
And you only trusted yourself there, as opposed to a system library that's trying to. It's like the serializers we're talking about. The system libraries for everybody.
The encryption library would be there only to respect the private, only to respect the security features. You can do it yourself, or the library can do it for you.
Right, that's what I'm saying. Yeah, I think that's fair. I think that's fair. So there's a version of the universe that says it's secure and the serializer won't break it open. There's a version of the world that says it's private and the normal reflection will break it open, but you can ask to be a serializer reflection and break
Of
it
course.
open. You can ask
Yeah.
for private. And I can come back to you and say, yeah, private's a convenience thing. I'll let you reflect on private.
That's
It's not
a
security.
middle ground. to
So
lead.
if my closures give me privacy, that's relatively straightforward.
Mhm.
I called a function, it created a function context, it created variables in that context. It returned something that had a reference to that. Fine.
Yeah.
How do you express this is a secret thing?
You use something.
It's
to
like one of the
say-
nice things about AA is there's not a whole bunch of keywords everywhere.
Right. So now there comes a thing of how do I declare you to be a secure thing and not a private thing?
Right.
I don't have
And
it.
it's not simply the closure construction that we had before.
Yes, I don't have a thing in hand for that. That gets into next sort of a typing game. Presumably, I want it to be poisonously typing so that if you load a secure thing inside the closure, which has to do something with it, call, SHA, blah, 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 SSH, whatever it's going to do.
If you want to be handled automatic, the type system should be expressed that something is secure in order to.
I'm not doing any inferencing. So somebody has to come along and add a type annotation that says secure. Actually, that is in the language as a type annotations have keywords like int.
But you cannot get away without annotation because it will conflict with the. You have to have either be a system function called secure and you enclose it in your state, or you have to type annotated as a secure.
That's some way to annotate.
I don't know, Cliff. It sounds like you failed with a type inference if it can't infer what has to be secure.
No, it turns out that there's no most general type here. I understand you're teasing, but there's a legit thing here.
AA has no concept of modifiers.
So back up. The issue here is what is the API that I want the outside world to see? I can't infer that I want the API to be that you can't see this field under any circumstances or you can. Because that's how you want the behavior to be the outside world. So as a minimum, there has to be an annotation that you tell me, I expect or intend this field to be not visible to anybody. Because otherwise, maybe if you handed a pointer to the object off, I would expect you to be able to peek through the pointer and go get fields.
So the main use case that's compelling you to not just do all closures are unpierceable by reflection is the serialize. You want people to be able to save certain objects to disk, even if they have internal state. And rehydrate them later.
Serialization is a entirely convenient thing. So I would like to say that there is a default on serialized capability, and you can turn it off on demand. By request, you can say, no, don't make me serializable. That goes hand in hand with I'm a secure field, no one can peek at me, because serialization is just another way to peek at a thing. So there's a cannot be peeked at. Then there is a inconvenient to peek at, which is what private is, which the intent is, don't depend on this because I might change its semantics or its implementation or whatever. Don't depend on this, but it's not security. And that would be Cameron saying private fields are not secure because serialization.
So private is a wonderful way to organize your own work.
Sure.
Yeah. So I want a private-like thing to organize your work, and I want a secure-like thing to be secure. And
I guess my instinct there is then that I want it to smell like frozen. I can build up my object, and then I can be like, okay, now the thing that I'm handing you is not my object. It's the frozen version of my object.
The frozen's a different thing yet again.
Like, you now can't mutate it.
Yeah, that's a different thing yet again. Yeah,
right, but you could do something that is roughly smells like that, where I've built my object that's my closure, and then I say, all right, the thing that I'm handing you is a opaque version, rather than giving you object, I give you object.opaque that returns the opaque version of the object.
Yeah.
And
that's
now
what we call a pure type, because basically the type itself has has all the signatures and so on, but beyond that, there's no substance whatsoever. So it's like, sure, you can call the methods that are exposed in the pure type. You can access the properties that are exposed in the pure type, but there's no structure. There's no class. None of those things exist. It's like you're dealing with something that's as solid as a cloud, literally. So.
Yeah, I'm missing the analogy. If I can call a method on it and it does something, then I call the method on it.
Yes.
You're talking about taking a struct and turning it into a collection of API interfaces that I can act on.
So when I use the word struct, I mean it almost like in the C sense. So every one of our objects has a struct. And if you instantiate that object in your container, you have access to that struct.
Right.
So privacy is just a convenience for a developer to keep themselves from shooting themselves in their own foot, right?
Right, right.
So our serialization, it just goes and gets the struct of the object and gets the fields and serializes them. No big deal, right? But if that object came from a different container, it leaves its class and its struct behind. And the only thing that comes into your container is the interface that's injected. And that's what we call a pure type, meaning it has no substance. We had to make up some word, so that's the one we made
Yeah,
up.
okay. So I'm going to
Okay.
rephrase to make sure I got it, but it sounds like you don't pass the memory around or the ability to treat it like memory. You pass the API around.
That's right. It's like a Java interface for all.
Yeah, you pass. Yeah, okay.
Like in Java, it's like you can't new an interface, you can only new a class type thing. Well, this is as if you left the class part of it behind and only brought in the interface. So it can't be cast back to its class. You can't ask it, what is your class? Like all those things just go away.
Right.
Okay. So what I'm picturing is something vaguely like this. If I have an object that has no opaque fields in it, and I say, great, mirror, please serialize this object for me. And I get back a string that if I pass to the reader gives me back my object.
Right.
If I have an object that has a secret field in it that is marked as opaque, and I call serialize, what I get back is a string that when I eval it, I get a function. And that function says, I take a parameter, and that parameter is a struct that's got the field path/to/secret. Please pass in a secret. And if you give me the opaque object, I will rehydrate you your thing. But if you don't have the opaque object, sorry, here is a function. Give me a thing to stick in the hole because I serialized a thing with 3 holes in it. Here is the API. Please pass me as an argument the things that go in the holes because the holes are holes.
That sounds interesting.
What are
but
holes? Holes are function arguments.
You
So
will
the thing I should give
change.
you is a function that gives you back your object if you fill in the holes.
That
because I've got opaques.
sounds interesting, but you have to change the signature of the function in
Why?
order.
Well, he's basically just currying his serialization.
Yeah, exactly.
Yeah, but
Yeah.
it will have to be instead of A to B, it will be a secret to A to B. If I understand it correctly.
Yes.
You
The
have to
serializer returns you back.
you have
not
to
a
allow the
string, but a
compiler.
function to a string.
You have to allow the compiler to work with A to B instead of secret to A to B. That's the thing here. If I understand.
Not necessarily. So
It's all easy.
my object is some tree shaped thing ish. Maybe it's got cycles in it, whatever.
Yeah.
So there's some path from the root of the object to the place where the secret is.
Yeah.
So the object that I need to pass into that constructor function is just a struct that has all of the segments of the path. So, it's a struct with a key path that's got a struct with a key 2, that's got a struct with a key secret. Great, path to secret. Here's my string that is my secret. Congratulations, I've rehydrated my encryptor.
You just pass the secret in and he would just jam it 3 layers in.
See, my problem with just passing the string that's the secret is
It gets big.
what if I've been building up my thing. So I've got my encryptor that's a secret, and then I've got my service that's got an encryptor in it. And then I've got my server that's got a service in it that's got an encryptor in it. And now I serialize the whole thing out.
Yeah, okay.
Like I really want to have that tree structure for injecting my secrets back in because my holes may be deeply nested. So I need ways to pass things in that are tree shaped.
I was coming up with a model that said I have a function that's got an argument for every missing secret. And you get a lot of arguments. And
my problem there is how do I name my arguments?
Oh, I don't care. They appear in the order that you have holes.
It sounds to me that
and I feel like they should be named path.to.secret.
Yeah, right.
And when I think path.to.secret, then
no, I'm not.
I think of a structure.
I have to think about what you just said. It makes sense to me because the other thing going on is I might have hundreds of holes, and I might need to fill in lots of things. And
If I'm doing a core dump,
yeah.
My server just exploded and I'm trying to do an entire heap dump of the entire server so somebody can debug it later.
Without all the secrets.
That thing's going to have a lot of holes in it.
Yeah, I wasn't thinking of going there.
Because
but
I
yeah, right.
basically
Yeah,
have to walk the entire memory.
Yeah.
And what I'm going to
but-
get is, here's your entire memory, but by the way,
Right.
you've got
Here's the entire
600
medical
holes in it.
database kept in memory as a array of structs. I want to serialize it, but all the social security numbers have to be secreted out.
Hmm.
So I want to
I
puke
would-
out a giant wad of string of JSON or whatever, but when I inhale it, you have to hand me back an array of social security numbers.
Like, I feel like this is very related to, if you get the serialization feature right, that can be your heap dump.
No, that's interesting too.
Hmm.
Yeah, maybe. I don't see why not.
Like, your entire heap is an object, essentially.
yeah, right.
It's
Yeah,
just-
yeah,
Or at least
just
that's
a
what
small
Smalltalk told me.
Just a small talk image. Yeah.
yeah.
And we've
So-
talked in the past about how do you dump and restore an entire heap so
Yeah.
that you have an ability to have freeze points.
So Aaron,
That may
if
also
you-
just be the same serialization technique.
If
It
you
gives you
have
a function for rehydrating.
if you have a class A and this class A has some private state in it and you serialize it, what would be the type of the serialization? It will be just
Function from opaque state to A.
okay. That's what I mean to have to change the signature. You have to include that it's opaque. And if you hand it to the other side, it will deserialize it and it would be opaque to a A. Is that correct? And you have to supply your opaque state in order to get the A back.
Yeah.
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 So how would you work with this state, because it have already be opaque to A? You have a function that takes only A. You have to beforehand you have to deserialize it or dehydrate it, supply all the case in order to use it. You cannot propagate that thing. You can instead on the other side. I don't want to
Why
use
can't you propagate it? It's just a function.
Okay, it's just a function, but I have a function that wants A, not opaque to A. Would I be able to use the encrypted state no matter I cannot peek through it?
You're
I have
talking
a-
about just
I
the
have a-
keys.
I have a function on the other side that just wants A, not the opaque to A, not the dehydrated class. In order to use it, I maybe would do something.
No. I'm handing you a serialized string and also a pointer to an A with an opaque field filled in.
Mm-hmm.
The guy who deserializes has to have that secret in the first place.
Okay.
So he's
And-
gonna, and the to an A part is simply a convenience, a way to conveniently hand me the missing field.
So we treat it as a deserialization operation with the
Well,
secret.
Now we're hitting into the land of generic deserializers versus secure fields. And if the other guy has the secret, is there a safe way I can make a deserializer that, given a string and a secret, I can make an object without blowing, and make an object, inflate an object, rehydrate an object, while also guaranteeing that the inflator cannot be doing anything cheaty or breaking any more security than he's already got broken, because he got handed the secret. And he has to read from a field in one place and write to another.
I have to give you a
We treat-
secret identifying token that can be used to look up the secret on the other side.
Something secret, yeah.
Another interesting point is that it just encrypt the secret. What I want to use just the public part of the public part of the class.
There's a thing that says I'm going to move a secret from point A to point B, and the secret happens to be embedded deep inside. And I was thinking I was going to serialize and deserialize. In my head, that one's solved by requiring you to write your own serializer using the standard reflection technology, where you have a key that you started with, but you shared with the other dude, and you serialized your secret using that key, and he decrypted it using the same key. So that one's solvable without requiring a language change or an OS change or a standard library change.
Yeah, agree.
Okay. Then there's the version that says, I have a secret and I want to use the standard library and I want to serialize it, and the serializer won't serialize my secret. Fine. The deserializer guy takes the string, he has the secret, however he got it, he wants to reinflate using the standard library. What permissions go in the standard library that are normal for every language, every place in every language, and every part of the language to use? Like, the standard library doesn't have any cheaty games that he can play. Like Java, we know, has cheaty games that the deserializer library plays. he actually doesn't break the model, but he does byte codes that do things, and he calls it unsafe. Okay, fine.
Mhm.
Is there a way that I can have the standard library read your object, which has an opaque field, and write it to inject it as without breaking the security, but having deserializer be written in normal code, not with a cheating backdoor in, right? And now I'm like, I think in this case, I demand the user have a constructor that takes the secret and an object that was built without the secret, and he merges them together and gives me an object with a secret in it.
Mhm.
And I'm going to call that version of the constructor, or a field by field constructor. I'm going to hand him all the normal fields I got from a string, plus the secret I pulled from somewhere else. That meant that via reflection, I read the secret out of this object and I put it in the constructor for that object. I can't read a secret out via reflection, right? That's the whole point. So now I need to come up with a way to get the secret out without needing reflection. So I need a version of an A where that field's not listed as secret. You put a secret in a field that changed from, it's private at the moment, I can reflect my way out of it. When I build a thing, it's secret.
Yeah.
And then I can't ever look at it again. Like the deserializer code gets handed the secret in plain text. He gets handed the secret.
So
But he's a normal piece of AA code, and he does normal things, and you trust him, and you can see his code. It's all open source. You understand he's legit. He just reads the secret and jams it. But he can't read a secret out of an object's secure field or secret field, because no one has that right to do it with reflection.
Yeah. And if a future runtime wants to do something like stick the secrets in a separate process, or stick the secrets in a TPM, like that's not, your language does not need to change. That's just an implementation detail of the thing I do with secrets is I encrypt them using a secret that's stored in the TPM, and I have to run through the TPM to get it to decrypt it, blah, blah, whatever.
The deserializer needs to be handed the secret, but he doesn't have to be handed it inside the field of the object where the field is labeled as secure. He just needs to be handed the secret. He can hand it to the constructor for the object and say, here's all your fields, including the secret. However that's done, and I don't have a good answer there, but there's something that says there's a way to do that.
Yeah. Which means you probably want to have the flexibility when I mark something as secret to say, here's how I would like you to
I might
redact
demand
it.
you provide.
This is the token I would like you to put in place when you see my secret. And I could either be really unhelpful and be like, your token is the string redacted. This is just not here. Or I could be really helpful and be like, your token is the ID of the virtual hard disk that you're connected to in AWS. So when I send the thing across the wire to the new server and I rehydrate it, the AWS interface can look at the thing and go, oh yeah, I totally recognize this special ID. I can reconnect you to that virtual drive and hand you back a new file handle and pass the thing on. Like it might work not just for secrets, but for any non-serializable thing, like a file handle or the clock or whatever. You just be like, yeah, the thing that's here is a file handle. Here's some information that is my redacted version of the file handle. And you want to rehydrate it on the other side. If that file's there to connect to, fine. If it's not, fine.
The transitive things in Java were there so that the rehydration process and the deserializer called arbitrary user code to rehydrate.
Okay, so if I have a Java object that's got a file handle, and I serialize it out, send it across the network, serialize it in.
Nothing. If you
what is in that spot where the file handler was? Just a null pointer?
No.
There's no such thing as a file handle. So
you have a file object. No, you can have file handles in Java. They're available. They're common. I totally did them. They're just off one of the fields in the file object.
But they're certainly not serializable.
If you serialize a file object and you deserialize it, you get a file object with that same handle, but its state is not open on that file. And operations you do in that file handle will now fail as it's an unopened.
Let's just say file closed.
It's an unopened file. So there's a transitive keyword, which was to say, serializer don't bother, deserializer don't bother, and then you would typically call the constructor who would then fill in the transitive fields. So this is in case you're or locks and file handles. Like I'm doing this H2O big data clustered fucking locks on one machine don't mean anything on another machine. You can't serialize a lock. Plenty of locking going around, people trying it or whatever. The answer was always on the other side, the constructor reinflated your transitive fields.
Okay. So yeah, secret probably smells somewhat similar to that.
Well, right. And now I'm trying to come up with what's the minimal API I need to reinflate the object with a secret field. Well, he has to be handed secret. Okay. So I have a generic code that works for everybody, getting handed secrets and schema for object descriptions, reflection, and he wants to inject those two in a way that doesn't break anybody or doesn't cheat in any way. I don't know, you know, he needs some way to say something like, hey, Mr. Object, making a new version of you using this secret and all these fields, these other non-secret fields.
Yeah.
And given a new thing, or maybe just make one with the secret, and then I'll just jam in via reflection all the non-secret fields, because I can do that via reflection. But I need user support to say, you know,
I feel like there's
without
the
the
outline of a
secret you're
good feature
missing-
here.
I'm sorry?
I feel like there's the outline of a good feature here, but could use a
Yeah,
little more
right,
thought.
exactly. We're kind of sort of beating around and getting close, maybe, right? I don't know what it is. But I'll claim that I've been convinced that privacy is not security. And that was, you know, Cameron's take there, fine.
And I'm convinced that we don't have to modify the type system to make this possible.
And I badly want to not modify the type system to make this possible. That's correct, that's correct.
It
Which
is
was
the
my question was, is this a concept that needs to exist in the type system? And the answer is probably secret is a type that needs to exist in the type system.
Yeah, I think that
But
one
it's
does.
probably not a concept that needs to exist in the type system.
Yeah,
Hmm.
yep. All right, I'm going to claim, you know, victory and lunch and all that kind of stuff.
Hmm.
And yeah, been a good conversation. And till we meet again.
okay, guys. Bye.
Bye.